Today we're going to continue our discussion about a high performance UCMDB push, and we're going to talk about class model comparison as well as fuses. So to get started, let's look at the class model. Class models differ between UCMDB and RTSM systems. In fact, they're quite a bit different. There are quite a few CIs that exist in RTSM that do not exist in UCMDB. Plus, customers may have created their own modifications, their own custom classes, their own attributes. And if specific content packs have been installed, for example, on one system and not on another system, that can also cause changes in the class model. Additionally, if you've upgraded the version of UCMDB over time, there may be differences in the class model between the different versions of UCMDB. Some CIs have been added in an RTSM system. Some CIs have been modified. And it also depends on the version of UCMDB that is running on both the target and the source in this case being UCMDB and the target being an RTSM system. So make sure that you examine the CI types that we're going to be pushing between the systems and make sure that the attributes exist on the target system. If you do not, these are most likely to show up as class model validation errors in the reconciliation logs on the target. That is, while we're inserting data on the target system. Don't skip this step. It's also important to make sure that custom classes or custom attributes exist on both systems with the same name because we can't map one name to another. Now let's talk about some fuses. So some fuses may need to be modified to suit your use cases, but it is important to note that we really need to be careful when we're looking at increasing or decreasing a fuse. Those fuses protect UCMDB from bad behavior. In a similar way, if you have a car stereo and that car stereo is worth $5,000, you have a 25-cent fuse protecting it. If you have an electrical surge in the vehicle, then the fuse blows, but the underlying stereo is not impacted. So you're saving yourself a $5,000 stereo. So by increasing that fuse, what you may actually end up doing is destroying the stereo part of that instead of fixing the problem. Now, what could that problem be? Well, we may have bad data in UCMDB, or we may have bad data in the target. You might have data in there that's incomplete on one system, or data that has default values in it. For example, a serial number that says no serial number. There's always things like that to be avoided. Now let's go ahead and look at a couple of the fuses. Now it's important to note, once again, I've already said this, but I want to say it again to make sure that I emphasize it. Don't increase these willy-nilly. Do not just on a whim increase these values. Now what you're going to see here are default values and maximum recommended values. But I will say that if you write the T-equals the way that I had suggested earlier, where we're pushing the node with the node layout, and then the second T-equal is pushing maybe some elements that belong to that node as well, and those relationships. When you are pushing data in that manner, these fuses probably will not need to be modified. If you're writing a poorly qualified T-equal with autocomplete turned on, the fuses can be exceeded. So it does behoove the user to actually create a very good T-equal with very targeted systems. So the T-equal max result size layout retrieval fuse. What does this thing do? Well, if you're using large T-equals, then we may not be able to load all of those CIs up into memory to be able to push them, right? So the default value of this is 2 million. The recommended maximum value would be 7.5 million, but keep in mind that the side effects of this fuse are memory usage. So if you don't have a lot of memory that's free on the UCMDB server, and you can check that in the JVM statistics, and you increase this fuse, then you may actually run into some memory issues. Next, the reconciliation data container size fuse. What this does is it increases the size of the bulk that can be inserted into UCMDB. Again, by creating good T-quals and splitting them out based on the node identification and then the additional related CIs, you should not need to increase this fuse. The default value is 100,000. The recommended value is 200,000. If you do run into issues where you need to increase this, the potential side effect is the memory used by the reconciliation engine. Use this fuse with extreme caution. I don't recommend increasing it above the recommended value. But like I said, good T-quals mean good data, mean that you're not having to do things like this. Another, reconciliation identification map entry fuse. If you have poorly qualified data, and what I mean by that is nodes that are very weak, they do not have a lot of identification information. For example, you may have a switch that has 1,000 interfaces all with the same MAC address. This is an M times N problem. So let's say that I have 1,000 CIs that I'm pushing and they all identify to one another. That's not just 1,000 would be the identification map entry fuse. The number that we would see for this would be 1,000 times 1,000. It's an M times N problem. That means that this fuse would need to be increased to 1,000,000 to let a bulk of 1,000 where we had all of those matching. It's important to take a look at the data that you're sending rather than increase this fuse. Once again, the default value, 5,000, recommended maximum, 50,000. The memory used by the reconciliation engine will increase, and the time that you take to insert those CIs will vastly increase. So it will slow down the push, it will slow down the insertion of data, and it could use tons of memory. This one is really not to be messed with. What I would do instead is look at the data that you're pushing. Do you have placeholder data? By placeholder data, I mean things like a serial number that says no serial number, or things like a BIOS UUID that says none detected, or something like that. It's placeholder data that makes a bunch of CIs match to each other. Don't push that kind of placeholder data. That really will cause some issues with UCMDB. Model top attribute instance fuse. What this will do is it will allow larger T-quals to be calculated. Again, if you're writing the T-quals the way I specified earlier, this should not be an issue. The recommended value for this, the maximum, is 2 million. The default value is 1 million. Increasing this fuse can cause memory and CPU to be used in UCMDB to increase. It would cause an increase in both memory and CPU utilization, and it may cause calculation issues. Commonly, the thing to do when you run into DFS calculation issues is to split the T-qual into smaller chunks. The way we wrote the T-qual earlier makes it chunk into smaller chunks by default. And so that is the best way to do this. So, again, this fuse needs to be used with extreme caution. The ad hoc task remote action timeout, this increases the amount of time that the integration point is going to wait for individual actions in the job. We actually do commonly increase this fuse. It is a fuse that's listed in milliseconds, so the default value is 600,000 milliseconds. The recommended value is 6 million milliseconds or 6,000 seconds, which is almost an hour and 45 minutes. Um, the side effects of this fuse is that it can take longer for it to time out if there becomes a problem, and that can slow down the failures that you receive. This fuse is actually not a terrible one to increase if it's going to take a long amount of time to do the insertion of the bulks on the target. Asset manager integration is a good example of, of an example where we would need to increase this particular fuse. The adapter ad hoc task remote pickup timeout is by default 20,000 milliseconds, and the recommended value is 200,000 milliseconds. This increases the amount of time that the integration point waits for the probe to pick up an ad hoc job. An ad hoc job means that I'm running it manually, not according to a schedule. Again, it's got the same side effects as earlier. Increasing this fuse can make the integration point timeout slower, which means that if you do have a problem, it'll take longer for you to figure that out. It'll take longer for it to time out. This is not a terrible fuse to increase, and we do see it in things like the asset manager integration, or you may have other integrations that take a significant amount of time. Thank you very much for your time. I appreciate your attention, and remember, writing good TQLs will solve a lot of these fuses. You won't need to increase them. Don't go above the recommended maximum values without somebody from Micro Focus R&D requesting you to do so. Thank you. Have a wonderful day.